If I had this idea at lunchtime, I'm 100% sure I would have thought this was a super bad idea. Because I had it when I was drunk already, I thought it made sense, and it turns out it does. So we hard-coded hallucination into models before computers could dream in color. They first had to watch a lot of cat videos.
To what extent should designers, media creators, artists, etc. see AI as an adversarial force?
Surprising how much of AI is just grounded in like our neuroscience and like how we learn and think about the world.
We love Apple. Do we? I don't know.
You guys are wrong. I'm right. I'm gonna go back home, drunk as I am, and I'm gonna make it.
Hello, everybody, and welcome to the Delphic Podcast. Here at Eurus Labs, one of the core aspects of what we're trying to build in this new world is to give people the best information about the state of AI, especially in how it has to do with media and people's ability to build cool new things. So we're super excited to have you here with us on this podcast. To that end, very quickly, before we start off, I would love to get some introductions out of the way. Mm-hmm. So why don't we start with Akshat?
Hi, I'm Akshat. I work with these guys on Eurus since about 2 months now?
Yeah. 2
months. We've known each other for 4 years. I have a background in AI, computer science, design, media. This is my third startup. 2 of them have failed. But I'm super excited to be doing this. And what I'm really excited about is pushing the boundary between AI being just a little ephemeral thing that developers and technical people use to something that everybody uses as a partner, as a little sidekick to do whatever the hell they want. Yeah, that's me.
That's awesome. Arsh.
My name's Arsh. I spent a bunch of my time after college working at an investment bank, Morgan Stanley, followed by McKinsey, where I was trying to grasp the business world of things. But before all of this, I was once an aspiring actor, a dream that I could never fulfill. But with the advent of AI, I finally saw the chance of people with no resources to be able to make high quality films. And that's what excited me about this project, and that's why I found myself with these guys.
Hell yeah. And hi guys, I'm Aryan. I fell in love with trying to tell great stories when I was about 14 or 15 years old. Since then, put up a bunch of live shows all around the world. We've made a bunch of films with our little independent film company that have won film festival awards at a few places, and I've worked at a couple of really large blockbuster films as an assistant director and such. I really am excited about the way in which AI plays into media generation at large. And what I'm really looking to sort of, explore over the next hour or so is the idea of to what extent should designers, media creators, artists, etc. see AI as an adversarial force in their life, and
or a sidekick,
or a sidekick, and sort of try and figure out why each of those things might be the case and how people might respond. So the structure of this is going to be super simple. We're going to start off with the past in terms of how Gen AI itself came to be, how several cool things happened that led to 2025 when AI is able to do a bunch of really cool things. Akshat is going to talk about the state of Gen AI right now as it pertains to image generation, diffusion models, the cool new stuff. And lastly, I'm going to talk about what the next few years might look like from a user perspective. The user being anybody from a professional sort of artist to someone like Arsh who wanted to make songs and now with AI is able to make some dope.
Yeah.
Some dope stuff, Ash.
Yeah.
So why don't we start off with the history and a little bit of context, Ash?
All right. So let's start off with the history of Gen AI in media.
Hell yeah.
So before computers could dream in color, they first had to watch a lot of cat videos. And before they could watch a lot of cat videos, they needed the ability to be able to see and to be able to deconstruct meaning from sight.
Right.
So that's a interesting.
That's
period.
actually really cool because that's something we just take for granted most of the time, like the
Yeah.
ability to recognize an object or a person or something like that. So when you say they needed to learn how to see,
Yeah.
what do you mean exactly?
Yeah. So we are able to ascribe meaning to objects just by looking at it. So I can look at this figure and I can see this and I can say, hey, this is my friend Akshat Rakheja.
And for all those of you who are just listening in on this, Akshat is looking highly dashing in a beautiful blue polo and some
Cheers
great
to
sneakers.
Lacoste.
Anyways, sorry. Back to you.
Right. And to be able to deconstruct this meaning, I need to know what it means. So the process of this first involved being able to know what an image is. And this is an interesting prelude to ImageNet. Now, ImageNet was a data set of 14 million images that were labeled in text that explained what was going on in the image itself. That's 14 million images, and the way to do it was actually much stupider than you think. It wasn't any computer science invention or anything of the sort. It actually was a bunch of outsourced labor by a whole bunch of humans that sat down looking at each image
This
one
is
by
very
one.
interesting. So was it like 14 million images of the same object, or was it 14 different, like
No.
all
It was
sorts of objects?
All sorts of objects. So ImageNet used Amazon Turk, and they like offloaded the job of labeling to a whole bunch of people. So human civilization as a whole sat down.
It's
labeled-
odd how that happened on Amazon, of all places.
Yeah.
So was it like you see an image, you describe it in a bunch of sentences,
Yeah.
or it's like you see a cat,
Precisely.
you see a cat?
Precisely. You see a cat, you describe what the cat is, and you describe some physical attributes of the cat, and there you have a labeled image of a cat, right?
Okay.
Entirely manual at first. So on the basis of that training data came AlexNet, and AlexNet is the first time that machines learn to see with real accuracy. So this is deep learning along with GPU vision.
This is really cool. Which year do you think this sort of?
Right. So this was 2012.
Okay.
When this came out, AlexNet, and it was able to label images with about a 15% accuracy, and that number pumped up to 40% when you use GPU. That was like the first instance of GPU vision.
Yeah.
And so with 40% accuracy, you can now do the same job that was done by ImageNet by actual human beings.
Yeah. What's so different about a GPU that allows it to go from 15 to 40?
Right. I guess it's the architecture of how it's built itself. Because it does parallelize processing, it's able to do a great job at representing pixels, which often work together. And so the first use cases of GPUs in general were in graphic
Gaming,
interfaces.
right?
Yeah, exactly,
Yeah.
graphic interfaces.
It's always the
That's
gamers
low.
who lead the way.
You know, when you said history, my mind automatically, like with any other industry, went back to like, okay, this must be 70 years ago. But
Yeah.
like AI is just like improving at an exponential scale.
Yeah,
So
this
even
is
like
nuts.
10 years ago, like 2012 was 13 years ago.
Yeah.
That feels like forever ago now. Because AlexNet, like I studied it in school, 2021, I got to NYU.
Yeah.
And I'm sitting there in the lab, and AlexNet was like the first thing we touched.
Yeah.
And the last thing we touched was not too far into what you're going to say.
Yeah, basically.
And that's
Hey, no spoilers yet.
No spoilers.
No spoilers yet. So around this time, we're still using, by the way, so this is seeing. But in terms of generation, we're like dark age. We're now,
So now we're just trying to get it to recognize something we put in front of it.
Classify.
Classified.
basically.
You
Nothing
see,
else.
a cat, it's not a dog, it's a cat. That's it. That's all.
And
it
this
is.
is all it's trying
This is
to
all it
do
could
with
do.
like 15% accuracy.
14 million images just to get to this stage.
Yeah.
Like 13 years ago,
Yeah.
that was the state of affairs,
Basically.
which is nuts,
Yeah.
right?
Actually, by this point in time, which is like 2012, we haven't even come up to VAs,
No.
variational autoencoders. So essentially, all of image generation that's AI based is just copy pasting back to. Okay, so the history of this is then, like around 2006, we came up with what is known as autoencoders, which essentially used to compress and then reconstruct data. So it would compress an image and learn which parts of the image are most important to recognize. Think of this in an analogy of how
Almost like if I see a wide horizon and a beautiful sunset and Arsh walking through there, I forget about the sunset and I just look at
Exactly.
Arsh, right?
Yeah,
Okay.
yeah, and we do this all the time actually. Like when we're looking at while I'm looking at an image right now, I'm never seeing any like the image as a whole. I'm focused on small parts of it, and my mind knows how to do this automatically. And that was the intuition that guided autoencoders, where they pick parts of the image that was most important to memorize,
Mm-hmm.
and then using that part, they used to reconstruct it.
So it's like extract feature
Yeah.
and reconstruct. But reconstruction was pretty bad at this time, I'm guessing.
No, reconstruction was okay, but it was very duplicative. It was
Mhm.
just able to duplicate in a worse way than the original image,
Mhm.
the original image that it saw.
Sure.
Cut to
Interesting.
2013, where we come up with variational autoencoders. So they introduce probabilistic, like a probabilistic understanding of the images itself. So instead of hard coding exactly where the image was, it was able to now introduce some sort of randomness to this, like, and smooth latent spaces.
Mm-hmm.
So
Um,
if we were to break that down a little bit, would you say that hard coding it is like remembering where every single pixel in an image of a cat is?
Exactly.
And probabilistic is what?
It's more like if I'm looking at a face,
Yeah.
I know where an eye should be,
Gotcha.
rather than at
This
X,
particular
X20,
point.
Y15,
Right.
Exactly.
an eye should be there.
Exactly.
So it's like a
Right.
variational autoencoder will sample from a latent space, so it walks across a latent space, so to speak. Whereas
What do you mean by latent space?
a latent space is anything that in a given pixel space
Yeah,
there could be. So that's a latent space.
gotcha.
So the probabilistic representation of a face
I see.
is a certain
I see.
sort of mathematical representation, and of a cat is another certain.
And that's really cool, because even with human beings, I guess I'm just trying to say that we do a lot of this as well as human beings, where
Yeah,
we
we
have a
do.
probabilistic sense of where a nose should be or where the eyes should be, and that's
It's surprising
really cool.
how much of AI is just grounded in like our neuroscience and like how we learn and think
Yeah.
about the world. The first intuition behind autoencoders was, hey, we don't see the entire image, we just see parts of the image that we think is
we
relevant.
see small parts.
Compress.
The second part of the intuition was that we don't even see parts of the image that are relevant in terms of I know this is there. I just know that it is somewhere
It's
around
most
this.
likely there.
Yeah, it's somewhere here.
Yeah.
Yeah.
So, would it be cool to say that if I were to take your face, Akshat,
Mhm.
an absolute approach would be to like sort of take an X coordinate and Y coordinate and say label your eye to be here, and a probabilistic approach might be like a heat map of the places in which
Sure.
eyes most likely
Sure.
are,
Yeah, in a
of
way.
which one of those is your instance.
Even the hard code wasn't quite hard code because it was still compressing. So it was still taking a lot of data, representing it as a smaller data, and then trying to sort of reconstruct that. But it was just not very good at the
Interesting.
reconstruction part.
Yeah.
And by the time variational came across, it could sort of like introduce some amount of variation or noise, but it still sort of faltered because the latent space was too closed, if that makes sense.
Yeah.
Like a face also has a lot of variation in it, like
Sure.
your face
Sure.
versus some different race, some different
Yeah.
nationality, right? Like, so that takes a little bit of imagination to like
Yeah.
make that leap.
Yeah.
And
Yeah,
that's
for
That's when we enter with...
That's the next chapter of it all. But
Look at it. This is all coming again.
But the cool thing from this was that at the point at which it became probabilistic and you introduced this randomness, what happened was for the first time, instead of reconstructing and duplicating the image from the compressed version, you're able to generate something that's entirely new. This is the advent of generation now. Like you're able to take a cat and try to generate an entirely new variation of a cat
that doesn't exist.
Revolutionary.
Cat doesn't exist.
A cat that doesn't exist.
Yeah,
wow.
cat that doesn't exist.
Right.
But it's still pretty shit. Right. So there's no commercial use of it. It's entirely based on research.
So this is actually super interesting because you say before this, these generative tools were making like a forgery in some sense of an image that you'd already fed it, right? But variation means it can make something new. But also what a lot of us have faced even now with AI, which is hallucination. It makes like a cat with 6 legs, right? So where is that line between variation and hallucination? And do we really need to hard code a bit of hallucination into a model in order for it to actually make something new? Like what's going on?
I don't think so.
Yeah. You don't think so?
No, I do think so. I'm saying how do we solve for that is the question. That's where the interesting part kicks in.
The entire beauty of this new form of doing things was that they introduced hallucination as a way to generate things. So hallucination is like often looked at as like a fatal flaw in models. But if you think about it, you need to be able to hallucinate to be able to generate new things. So it's not an inherent flaw as much as it's the very thing that creates the magic of generative.
That's really cool. But so how do you then take something that can hallucinate and sort of try and make it hallucinate less?
Great. This gets us to 2014, Ian Goodfellow. Now, Ian Goodfellow is he was an interesting character. He was my best understanding of him is he's an egotistical man. He was, you got to be at...
but very, very smart egotistical.
No, very smart egotistical man. And he sat down, he went to a bar with a bunch of his friends, and his friends like to talk about AI. And they were debating about how useful AI is going to be. Is it ever going to be able to generate anything meaningful?
Nerds.
What about us? So he sits down in this bar, right? And he tells them that, hey, I think they can do, like, AI can do a great job at generating image. In fact, I have a concept of an idea.
Hell yeah.
Oh, don't we love it? Don't we love it when that
concept
happens?
of an idea. Yeah. And he came up with this cool idea. He was like, what if there was a generator and a discriminator that were both competing with each other?
Sure.
The discriminator's job is to catch
the generator.
Is
really cool.
Yeah. Think about it like a person who's supposed to forge and a person who's a policeman who's detecting the forge.
Right.
Right. And
whoever
gets...
And that only makes the guy who's doing the forging a better forger.
Yeah.
Right? It's like Leo DiCaprio and Catch Me If You Can and Tom Hanks.
Like if Tom Hanks is not really good, then Leo DiCaprio is not as good, right? Makes sense.
Basically.
Okay. Back to Mr.
All the way down to Friedman, man, like competition introduction.
Love it.
So this idea itself sounded great, and his colleague said, idea sounds great. But I don't think it has any practical application. I don't think this is, like, it's possible to train training one neural net at that time was hard enough. Training 2 neural nets, making them compete with each other, that was like a very difficult architecture in general. So he had to build that for image generation. This is a big thing. And it's now 10 p.m. He's drunk. He's had an argument with his friends. And he's like, you know what? I'm going to build it tonight.
I'm a prove a point.
You guys are wrong. I'm right. I'm going to go back home, drunk as I am, and I'm going to make it. And he did. He went back home to his room. He was drunk off his ass. He built it. He later went on to a talk show where he... went on to say that, hey, if I had this idea at lunchtime, I'm 100% sure I would have thought this was a super bad idea. Because I had it when I was drunk already, I thought it made sense, and it turns out it does.
You gotta introduce some hallucination.
I think you need to introduce
hallucination is the secret.
So tell us more.
Yeah, so GANs...
Wait, but didn't like Jensen Huang have something to do with this? I feel like, wasn't there something?
Yeah, so GANs use GPUs. GANs use GPUs to make it work. And when GPUs were being shipped out of Jensen Huang's factory in NVIDIA, Jensen Huang is the type of man who's very analytical in these things. So he's like, if people are using this, my technology is being used to build something. Can I just build the technology itself? Once GANs was popular, and GANs was super popular because it started off with like being able to generate images in a blurry-ish kind of way. It didn't make sense, but it got progressively better over time. Again, this was like unsupervised learning, neural nets that was doing a great job at creating images. He realized that he could be able to, if you could allow people to change the style of an image, like attributes within an image, you could be able to do a much greater job. So he came up with, NVIDIA launched Style GANs, and that was the first commercial moment of...
Was this like all the deepfakes that you kept seeing online?
Yeah. 2018 was a crazy time. Styles GANs came out. This is 4 years after GANs first got published. Style GANs comes out, and there's the site. I don't know if you guys know the site or not. It's called thispersondoesnotexist.com. Now, you go on thispersondoesnotexist.com. Every time you hit a reload button, you see an image of a person.
Of a brand new person who does not exist.
Of a brand new person that just doesn't exist. It looks super realistic. There's no way to tell. And even now, when you go on the bottom right of the image, you still see Style GANs.
Oh, really?
Yeah,
That's pretty cool.
You still can. And so they came up with that, and it was a hit. It was the first time consumers, like end consumers, were playing with the AI tool. And the site went instantly viral.
Wow. There was also a bunch of these Tom Cruise deepfakes around that time. Do you remember that stuff?
I remember that,
But that also made a bunch of people really apprehensive about this technology at large, right? This is the time when people started going, wow, I can't really believe in like...
it's very controversial.
I'd say it was super bad at generating images of people that were already real versus recreating fake images. Like, do you remember the time, who was the actor who slapped
Will Smith?
Will Smith.
Yeah.
Like, have you seen any of those videos that show Will Smith in 2018, the fake of him eating cereal versus Will Smith fakes now?
Yes, I have.
It's a world
We
of
should
difference.
probably show that to people.
Yeah.
If
We
you're
can play that
listening
right
in,
now.
you should just check the video out at this point.
Right. So that's a transition it made from in that 2018 to 2024 now.
This is nuts.
The 6 years.
But there were major issues with GANs. That's why they survived only from 2014 to 2021 or so.
GANs died. GANs died too. And GANs' death was for a bunch of reasons. I can explain one. One was mode collapse. Now, this is super interesting. It's a very... So, the impersonator in this case realized that instead of generating new images that might get flagged each time, what if I took an image that already worked and just kept showing the detective the same image again and again and
As
again?
soon as it was success.
Yeah.
It's like being a one-trick pony, right?
Yeah, it was a one-trick pony.
Yeah.
Because it sort of started from absolute randomness and it worked its way up to coherence. So by the time that it got to, okay, this is success, a lot of the mode collapse was like, okay, I've hit a point of good, I don't need to do more.
Yeah, exactly.
And that's why the training it sustainably was the challenge with GANs. It was a beautiful model. The sampling was really fast, but it was one pass of sampling and it was immediate, okay, this is true, move on. So mode collapse was just natural.
Yeah, so GANs had to die and GANs had to lead the way to something much dumber, much simpler. But before that, we have to cover OpenAI. OpenAI, by this point in time, this is 2021, had come up with Clip. Now, Clip is a text-image shared embedding space. It basically, it was the thing that linked language to vision. In itself, it was just useful at describing images and deconstructing images, like the interplay between text and image. But when combined, and a lot of indie hackers actually did this, like a bunch of like people sitting down on their own laptops. Indie hackers came up with this like very hacky mix of VQ GAN with Clip, which is a GAN variation of vectorized space. And they got that together to be able to generate this like entire wave of AI artwork. It was very
Is this that dream-like hallucinogenic,
Exactly.
you're on
LSD.
Yeah.
Yeah, it felt like
I
a
just
trip.
dropped
Like,
acid. That's pretty good.
yeah, and this is like the peak of hallucination models, and like it was doing like all kinds of crazy things.
I actually used some of that for a film to show like a bad dream or something like that
Oh,
back
yeah?
in 2022.
Look at that.
Yeah, that's
Yeah.
insane.
Yeah.
That's crazy.
Yeah.
So this was the state of the art at the time, right? Clip explains the text part of it, and then you can take text and generate stuff out of it. This is important because it allowed people from just commanding text lines to be able to generate stuff, see how it felt like, as opposed to this person does not exist.com, which had like a pre-trained model you had loaded each time.
Sure.
And it was utter randomness was another thing about GANs. It was you always started from noise.
Yeah.
Utter noise, which was like basically things that you couldn't tell was an image.
Sure.
Maybe just static.
Right.
And it worked its way up to coherence, which is why it was like you couldn't have I want to see a cat with bunny ears. You know what I mean? Like
Yeah.
yeah.
Interesting.
But then we get to the death of GANs and the rise of diffusion models. Now, diffusion theory was old. Basically, 2014 was when GANs came out, 2015. This guy called Sol Dickenstein comes up with the diffusion theory. He says that you don't need to do all of that. No. This can be done much simpler. How about you take an image, add noise, right? And then add noise to a point where you can't see anything in the image except for noise, and then teach a model to deconstruct the original image back and use the original image as the standard bearer, as a checking point of how accurate this denoising is, instead of having this two antagonistic neural nets fighting each other. It could be done and all the limitations that came from that, you could just do reversal of noise.
Exactly.
So
Right.
explain to me how the workflow of something like this might work.
Gotcha.
Right? Like how, like you take an image of my cat Lexi, right? You introduce noise to that image, right? Then you give both images to a model and tell it to go from image number 2 to image number 1, and then use image number 1
As a benchmark.
to
So
do
it did loops of denoising. So a big thing, as I said with GANs, was that the sampling happened once. In this, the sampling happens 10 to 100 times, which means
Gotcha.
that you denoise, compare, denoise, compare, denoise, compare, and at the point at which you get to a state of coherence, super clear image, and very similar to original image, but with its own little take on it. So that's why it's called a diffusion model.
Yeah.
Because it diffuses into
Yeah.
noise, and then it comes back
to
into
image.
That is really cool. And so diffusion models were the start of when things started to go really crazy.
Yeah, basically. And that leads you to the launch of DALL-E 2. Now, DALL-E 2 is one of the lesser known inventions of OpenAI.
What a banger.
Yeah, it was a great.
No,
thing.
that flipped my mind.
Yeah.
I was in class, I remember that. I was just thinking.
Yeah.
Yeah, people are surprised when they find out that actually ChatGPT had a bunch of viral moments before ChatGPT. The reason why Sam Altman was so shocked that ChatGPT took off was when he came out with DALL-E 2, he was like super optimistic, saying that, hey, this is going to go viral. This is crazy what we built. But it turned out to be...
I guess people just wanted to talk at the end of the day.
Yeah.
Maybe shout out Eurus.
Maybe that's the
Yeah. So DALL-E 2 takes a clip that OpenAI by this point had already invented of like understanding between text to image, and then that they put it instead of in GAN-based protocols, they put this inside diffusion models. And they come up with a diffusion model that they merge this together with, and that is now able to generate very high fidelity images just from single prompts. Like it can actually generate things that look like plausible. It looks like animated characters and all of these things. It wasn't realistic to the point at which it has gotten now, but it's still like really, really cool things that you'd find across the internet being generated just from text.
Interesting.
It's brilliant.
Yeah.
So is that the backing between like DALL-E 2 and Pika and all of those other ones?
Yeah, so we had to make a bunch of innovations since then. Like right after DALL-E, Google also launched ImageNet, very similar architecture.
And ideogram or something like that?
Yeah, ImageNet and
I remember
ideogram
that.
came around the same time. So this is like the race is on.
Yeah.
The race is on, and much like ChatGPT, OpenAI was the first to lead the punch in even this space.
Is it true that like diffusion is what led to the stuff that we're using today, like Runway, Pika, these like offsprings of?
Yeah.
100%. Now, like, so diffusion is now like generally accepted by the industry as the thing that works. We had to get to latent diffusion to be able to make it actually efficient and cost efficient in training itself.
Because diffusion itself, since it's taking all those loops, is
Yeah.
very heavy on the memory. Like
Yeah, it's
GANs,
super heavy.
the amazing thing was it was one pass, it was
Light,
quick, it was
right?
light and worked. But
because it
wasn't-
only sampled once.
Exactly.
Yeah.
So now we need to get to latent diffusion to make it commercially viable.
Yeah, so latent diffusion comes out with this open source model, as all good things are. Open source model, stable diffusion. This is the first time where this powerful technology now is no longer closed source, it's open source. And it comes with latent diffusion, which essentially is noise added to a compressed feature space. So instead of noising and denoising everything in an image, it noises only small parts of the
A
image.
tight feature space.
Exactly.
Yeah.
Exactly.
Wow.
And that makes it super efficient, super cost, super cost efficient, efficient training, not terrible for your GPU.
So it seems to be the case that efficiency is a product, relatively speaking, of like directing the work that the model has to do to a very constrained space and
Right.
then making change, like whether it's with GANs, whether it's with anything else.
Even
right?
autoencoders all the way back.
Even, yes.
Yeah.
I mean,
Exactly.
most of CS was built this way, right? Like you wanted to build C++,
Yeah.
but you had to make it compile time really tight so
Yeah.
that a commercial user could build a website out of it,
Yeah.
build a backend out of it.
Yeah.
Like, that's what all of CS is, because we
Yeah.
sent people to the moon with like bits of space.
With less with less RAM than probably the liquid display
Oh,
on,
absolutely.
on the iPhone takes on a single scroll, right?
Like,
you
we
know.
love liquid glass. so-
Hey,
so-
we
so-
love Apple. We love. Do we? I don't know. Okay, but you were saying.
latent diffusion.
So latent diffusion comes out, stable diffusion releases the model. Now it's open source. Open source is cool. Open source is cool because a lot of developers sit down and innovate on top of it.
Yeah.
This is the birth of the things like LoRa that are now used by everybody. And Akshat's going to cover this in the present segment. But there's one final piece of this history that's not so much history as it is like shit that's happening in our like
Now.
you can remember
Yeah.
this. So remember the criticism around image video models initially that they have no spatiotemporal consistency. Like,
Yeah, right.
Like a person walks and then suddenly they
He
go
sort of
and-
flies into the air or
Yeah.
something.
Exactly,
like that, right?
exactly.
Yeah.
That's a big problem,
Yeah.
right? It's very hard to solve for this because the way you're making this is just like you take noise and deconstruct it.
Right.
It's not linked to any spatiotemporal elements yet. So then comes transformer diffusion, right? It adds temporal modeling with attention. This is all the way back to attention is all you need. That famous paper, I think Akshat can explain more
Ilya.
about it. Yeah, Ilya's paper. And they apply this now to media generation. And that is the birth of Sora. And Sora is the first model that is able to do that. Cut to now, there's a whole bunch of models, Runway, VO, that have improved on it. They've added multimodal to this. So like Google's VO2 model does that. And
So-
this is where I think you should take this on.
So when you say spatio-temporal elements are added to the model, what does that mean? Like it understands time and space, or like that's
Physics, baby.
Okay.
It's physics.
Okay, got it. Yeah.
That's
Yeah.
how you got to say.
No.
Yeah.
It was the first model that's able to think through the physical realities, and this is something that we are very tuned to doing automatically. Like
Yeah.
we are able to understand.
Even an animal. right?
100%.
Yeah.
Like if I throw you a ball, I am able to, and Akshat's gonna take this part in the world models part of it. But like if I throw a ball, I can picture where the model is gonna be on the basis of a core ingrained understanding of the spatiotemporal.
How
And
things
not even
move.
not even just where it's going to be at what time. Right, like that's how you
Right.
let a baseball get caught or a cricket ball
Yeah.
get caught.
Yeah.
Because
Yeah.
you can sort of map out a trajectory in certain like milliseconds
Yeah.
of
This
time.
is really cool. I think there was this like study that was done where Ronaldo's heading is something that a lot of people talk about, right? So what they tried to do is they gave him a cross,
Right.
and they shut the lights,
Right.
all the lights.
Oh yeah, I saw that.
When
I've
the
seen
ball
that.
was midair,
Uh-huh.
and he was in utter darkness, able to know exactly where the ball was going to be at what point in time,
Yeah.
and then able to hit it into the goal. So it's not so. What is that kind of understanding?
I mean, think about it like when you play table tennis, right? When I hit a ball, you don't have enough time to be able to gauge and react to the ball if you were just at this, like if you were only hitting the ball at the point in which it appears here,
Yeah.
then you would never be able to position yourself in a place where you can hit it right.
That makes sense.
Because human perception is 20 milliseconds late than reality.
Yes.
Yeah.
So by the time the ball arrives, you're already smacked in the
yeah,
face
yeah,
with
smack
it.
in the
Yeah.
face with it.
Yeah.
So you need to build worlds in your head. Like you need to build scenarios of what's likely on the basis of all of the training data you've had by
Yeah.
looking at visual data of where the ball is likely to go. And you come up with 2 or 3 scenarios, and that collapses into one singular scenario where you put your racket at a specific place at a specific time, and that's entirely imagined. And that's imagined with
Yeah,
an
it's
understanding of spatio-temporal laws of nature.
We watched this video by Kyrgyzstan.
Kyrgyzstan, yeah. They had a super
YouTube,
video on it.
and that was phenomenal. Is that you are really living in a simulation by yourself.
Yeah.
Yeah, something like that. It was like, and it used the table tennis example exactly. Yeah, that was
Yeah,
interesting.
that's where I started
And
from.
what I really love about this is that people think imagination is this sort of thing where, oh, you got to be imaginative and write poetry and shit
Yeah.
like that, right? But I think in order to overcome the system lag that we have as human beings,
Yeah.
the tool that helps us overcome that system lag is imagination.
No, absolutely.
Right? Like
Absolutely.
it's a very functional thing to be able to
Yeah.
imagine what's likely to
Exactly.
happen.
Exactly.
Yeah.
Right?
Like this is to our point early on, right? Hallucination is the very thing that makes AI. It's not only the weakness of AI.
Yeah.
It's the very thing that creates
Right.
the magic of
Well,
it.
that's,
And then-
that's the weakness and the strength of
And
us.
then
Yeah.
hallucination within a set of constraints.
Oh, that's wonderful then.
That is
That's
where
a
the
word.
magic happens,
Yeah.
right? Like a set of true constraints,
Right.
let's say.
Yeah.
Yeah.
And that brings us to the end of episode 1. We covered everything from ImageNets all the way to stable diffusion and diffusion models. We went from a history where AI went about trying to be able to understand and see cats all the way to a point where AI can now imagine entire worlds. And the best part is that this is just the prelude. Because what's coming next is not just about the state of AI, but also the complex set of real world consequences that emerge from it. I'm talking politics. I'm talking about the entire infrastructure of creativity that has been displaced as a result of AI and what becomes of the future. But more on that on the coming episodes.